In this problem, we're given the graph of a quadratic function and asked to find all of the key characteristics. We first want to start by finding the domain of the function. Remember, the domain is a set of all possible x values or inputs. And since the x-axis is the horizontal axis here, notice how, while we can see the graph is moving up very quickly, it's also moving left forever and right forever without any holes or breaks. And therefore, if we were to project this graph onto the x-axis, it would move to the left forever and move to the right forever, and therefore the domain would be all real numbers, which is a domain for all quadratic functions. We can express this several ways. Using interval notation, we'd have the open interval from negative infinity to positive infinity. Of course, we could also say x is greater than negative infinity and less than positive infinity. These two are equivalent. The range is a set of all possible y values, and since the y values run along the vertical axis, we can think of projecting this onto the y-axis, or notice how the lowest point on this graph is at the vertex where the y value is -4, and then from -4 the y values increase without bound. Therefore the range would be the interval from -4 to infinity, closed on -4 because it does include -4. So again, using interval notation, we can say the interval that's closed on -4 to positive infinity. Or using inequalities, we could just say y is greater than or equal to -4. Again, these two are equivalent. Next, we're asked to determine when the function is increasing and decreasing. Informally, if we walk on the graph from left to right, if we're going downhill, the function is decreasing, and if we're walking uphill, the function would be increasing. Again, when walking from left to right. More formally, if as x increases, y decreases, the function is decreasing, and if as x increases, y increases, the function is increasing. So looking at the graph of our function, notice how on the left of the vertex to the vertex, the graph would be decreasing, and to the right of the vertex, the function is going uphill or increasing. When giving the interval for which the function is increasing or decreasing, we want to use x values. So notice how the x value of the vertex is -3. So the function would be decreasing on the interval from -infinity to -3, and it's increasing on the interval from -3 to infinity. And we're not going to include -3 in either of these intervals. So the function is increasing to the right of -3, so from -3 to infinity, or if we want when x is greater than -3, and it's decreasing on the interval from -infinity to -3. Again, both intervals are open on -3 because -3 is not included. So we could say this would be when x is less than -3. Because the parabola opens up, the vertex would be the low point on our graph, which is here with an x-coordinate of -3 and a y-coordinate of -4. So this would be the vertex. Remember that the vertex is also the only point that's also on the axis of symmetry, which would be this vertical line here, x equals -3. Next, we're asked to find the maximum or minimum function value, and because this parabola opens up, we are going to have a minimum value which would occur at this low point, and the minimum value is actually the y-coordinate of the vertex. So the minimum value is y equals -4. Finally, we're asked to find the intercepts. The x-intercepts are the points where the graph crosses the x-axis. Notice how this parabola has two x-intercepts, one here at the point -5, and one here at the point -10. And the y-intercept is where the graph crosses the y-axis, which occurs here at the point 0,5. I hope you found this explanation helpful.